Right, I'm going to put together those three log rules we just learned in the previous video. Product rule, quotient rule, power rule, okay? So, here we have a single log. I'm going to split it apart into separate logs. Okay, so we have a couple of things being multiplied on the numerator. Okay, so I have this. Log of x to the 8 plus log of z, okay? Because here are two things being multiplied, so it's two separate logs, there's a plus in between, okay? Because this is the division, this is going to be a minus log y cubed, okay? So here we go. 1, 2, 3 separate logs because I have a 1, a 2, a 3 separate terms there, okay? Okay, now then, all you have to finish off is the power rule, and that, remember, is put these exponents to the front. So the final answer is 8 log x plus simple old log z minus 3 log y. Okay? So I'm going to erase that, so you're going to pause that and see, but that is the answer. Okay, split it into separate logs. Right, okay, on to question 15. Now then, you know what I'm going to do for question 15? I'm going to change this 7 to a 9, okay? That 7 is now a 9. Right, so here we go. I still have 2 things on the numerator and 1 on the denominator. So here we go. Log to base 9 of the first one, which is the 9, plus log to base 9 of the root x, okay? And then finally, because this one here is on the bottom, minus log to base 9 of the y, okay? So again, a 1, 2, 3 things, a 1, 2, 3 separate logs. Right, here we go. This log to base 9 of 9 is 1, because 9 to the power 1 is 9. Now watch this. This is what you have to do when you see these radicals. Change it. Remember, the square root of x is x exponent a half. That will eventually come to the front. And then nothing to do here, just log nice 9 of y, okay? This is going to come to the front, so the final answer is 1 plus a half log to base 9 of x minus log to base 9 of y, okay? That's it. I'll just kind of quickly show you some of the harder ones down below here. And if you see something like this one, which is nasty, remember, a radical, square root, we can write a 2 there. So what I've got actually here is this. I'm going to write this just in terms of exponents, not radicals. This is the kind of stuff you're supposed to know coming into the college algebra. It's usually taught heavily in intermediate algebra. Right, x cubed, but the square root of it, because I've got to apply this to each one of these 1, a 2, a 3 terms. X cubed, if I square root it, is going to be x cubed. Square rooted means that. So, of course, that will go to the front. The y term is on the top, so plus log. Now, 2 over 2, I can write it. It's log to base b still of the y. And that's going to be 2 over 2. That'll just be 1, of course, eventually. Minus log to base b. If it's z to the 5, but square rooted, then it's z to the 5 and square rooted. Okay? So all of these will come to the front. So the 3 over the 2 is at the front. When I think about it, that's just 1. So nothing's going to happen there. You don't need 1 at the front. Minus 5 over 2 log base b of z. And that, folks, would be the answer. Okay, so a little bit trickier. Things to remember. If I'll just do quickly one by itself. If I do this, log x over y z, where I've got 2 things on the bottom, well, it becomes this. Log x minus the log y minus the log z. I know that some students think, okay, well, because these are 2 things being multiplied, it should be a plus in between, but of course, because they're both being minuses, it's like saying, okay, you're distributing the minus, so that and that. Remember, both these things are from the denominator, so both have the minus log, okay? So little things to remember there.